Okay, hello everyone. In this video, I'm going to discuss about AC/DC rectifier. Okay, AC/DC rectifier. So in this video, we will focus on single phase half wave uncontrolled rectifier. So uncontrolled means that we use diode. Okay, in this video we focus on our load, just resistive load, only RL. Okay. Okay, this circuit show a half wave rectifier. So we know that rectifier, it will convert from AC to DC. So the input is AC, input side is here, output side will be here. Okay, our input is AC, so we know that for AC we have sinusoidal. For example, this one, let's say this one is V max, Vm. So our source is Vm sine omega t. Okay, sinusoidal. So the output will be DC. Okay, DC. So we already know. I think you learned before about the diode. Okay, how the diode work is the diode is only can work during uh, forward bias only. Forward bias. During reverse bias, that this diode will be off. It look like switch, so one-way switch. Diode can conduct current during forward bias, and it cannot conduct current during reverse bias. So let's start. Okay. So okay, this is the input waveform, Vm, Vs, source voltage source is here, Vs, V out, we take V out here, I out is here, okay, I out, V diode is here, diode voltage. Vd. Okay. Okay, let's analyze it. During positive cycle, during this cycle, between 0 to pi. From 0 to pi, our input is sinusoidal positive cycle. So plus here, minus here. So current will flow this direction. Okay, we can see that this diode and the current same direction means that this diode will be forward bias. Okay, when diode forward bias, it look like switch on. So current can flow. This is we call I naught. Current can flow means that when the current can flow, so there will be drop of voltage here. So V out will be same as Vs. Okay, same as input. All the input voltage will go to output voltage. So our output will be same as the input. Okay, look here. Okay, this is our output voltage during positive cycle. This is the input voltage during positive cycle. So same. Output equal to input, exactly same. Okay, in this case we assume there is no this we become ideal diode, so there is no voltage drop here. If we use real diode, for example, we use silicon, so they will be dropped here 0.7, 0.7 if you use silicon. If you use germanium, 0.3. So in this case, we just use ideal diode. So there is no voltage drop. So this means the output is exactly same as the input. So output waveform same as the input waveform. Okay, so it's during positive cycle. Okay, the next is during negative cycle. What happened? Okay, let's look here. During negative cycle, let's say we use green color. Negative cycle, the input is negative. Negative waveform means that will be like this, negative here, positive here. Okay, current will flow this direction. Okay, negative cycle here. So what happened? Okay, we can see that flow of current like this. Look here, diode like this. So what happens to diode? This diode will become reverse bias. Okay, when diode reverse bias, there will be open circuit. Reverse bias, open circuit here. So when open circuit, current cannot flow. I equal to 0. So when I equal to 0, there is no voltage drop here. Means that voltage drop will be equal to 0. 0 volt. Okay. This one is during from pi to 2 pi. Okay. At this time, there is no voltage drop here. So 0 volt. Okay. The output will be 0. Okay. Current also 0. Okay. In this case, okay, current I naught is equal to, we can see here, I naught is will be equal to V naught over R. Okay, I naught is V naught over R. V naught divided by R. So same angle, however, the magnitude is less compared to voltage. So V naught divided by R. We can see that less than R. Okay. Then during, so from 2 pi to 3 pi, we just follow the previous one. Okay, this one, so they will be follow same as positive cycle. So they will be continually cycle. Okay, for diode voltage, okay, during for diode voltage, okay, during positive cycle, okay, this one is positive cycle. In this case, positive cycle. So our diode forward bias. So forward bias diode will be short. So there is no voltage drop. Short circuit. Diode becomes short circuit. So means that short circuit is equal to 0 volt. So during positive cycle, 0 volt due to short circuit. Okay, diode short circuit. Okay, during negative cycle, okay, this part from pi to 2 pi, what happened? From pi to 2 pi, flow of current will be like this. Diode open circuit. So, what is the voltage drop at this diode? Vd. Vd will be equal to same as the input due to there's no drop here, no voltage drop at the resistor. So Kirchhoff law say that total voltage equal to 0. So total voltage in this loop equal to 0. So that means Vd is equal to V in, Vs. Okay, in this case, so Vs like this. So Vd is exactly same as Vs due to no voltage drop at the resistor. Okay. One is how to draw the waveform of the voltage source, of the output voltage, of the output current, and also diode voltage. Okay. Now we, in terms of equation. So the equation, okay, what is the output voltage? So output voltage. This is output voltage here. So let's erase first to make it easier. Okay, let's derive the output voltage equation. Let's say this is our output voltage. Here is output voltage, VO. Input is Vm sine omega t. Output voltage is here. Voltage drop at a resistor. So input voltage is here. So the average output voltage will be here. It's maximum. The effective voltage is the average voltage. So the output voltage, the average output voltage is equal to area under the curve. So area under the curve, so this area. For the time time period is t. Area under the curve. So in this case, we just have one curve. Area divided by t. Area is equal to so 1 over t integration from 0 to pi. V in this case is VL, V load is V out. Okay. T. Okay. Now we will get 1 over pi is equal to T is equal to 2 pi. Zero pi. V out will be same as the input. Vm sine omega t d omega t. Okay. So when we derive it, we will get 1 over 2 pi sine is equal to minus cos. Pi 0. So we will get 1 over 2 pi. Sorry, this one is Vm. Vm take out. Equal to Vm over pi. This is V average. Okay. Next is current. So current I out. I out is equal to I average. So I out equal to V average divided by R. I out is here. So we get Vm over pi R. Okay. This number 2. The next is VRMS. VRMS means that root mean square. Okay, root mean square. Mean, sometimes we call mean, sometimes we call average. So root mean square means that the average voltage square and roots. Okay. V average square root. Okay, we will get So V average square is equal to, so take this, V average square is equal to 1 over 2 pi, okay, 0 pi square, Vm square, sine square, d omega t, sorry, dt, d omega t, sine omega t dt. Okay, so we can take out Vm, we will get Vm square over 2 pi 0 and pi. So this we can simplify using identity. So identity, we know that sine 2 omega t will be equal to 1 minus cos 2 omega t divided by 2. So d omega t. So when we solve this one, equal to Vm over 2. This one is VRMS. Okay. Number 3. Okay. Number 4 is IRMS. IRMS is just equal to VRMS divided by R. Okay, in this case, Vm divided by 2R. Okay. Number 4, this one is IRMS. Okay, number 5 is output power. So we know that output power will be equal to VRMS square over R or IRMS times R. Okay, this one is output power. This is an important terminology in rectifier. Okay, this number 6 parameter is conduction angle. Okay, gamma. Okay, conduction angle of the diode is up to what? Up to what angle? Up to what angle the diode is conduct? We just refer to diode with voltage graph for diode voltage. So up to what angle this diode conduct? So in this case, the diode conduct means that they conduct from here until here, until pi. So conduction angle is equal to pi. Okay, up to what angle the diode is conducted? Okay, the 7 parameter is extinction angle. Okay, extinction angle is called beta. Beta is extinction angle. Extinction angle is up to what angle the current flow. The diode current flow through diode. Okay, look at the current response. So we can see that in this case the current conduct, the diode conduct current up to pi. Okay, it's equal to pi. Okay, this is number 7. Okay, number 8 is PIV. PIV is here. PIV, peak inverse voltage. So peak inverse voltage equal to Vm. This is number 8. Okay. 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 I think that's all for important parameter in AC/DC single phase half wave uncontrolled rectifier by using a resistive load. Okay, RL for RL nya. Okay, thank you. That's all. Bye bye.